record on this computer. So the recording is helping, right? You're able to utilize it, or you just receive it and then keep it?
No, sir. It's using the guys who are not joining, those who are not getting internet, they are getting used.
Oh, okay, okay. So basically it's useful then.
Yes, sir.
So in case I forget on any day, please also remind me. I have another small meeting at 1, so I need to close it before 1. Okay,
Okay.
let's start, sir. Okay, we are talking of a new topic which is called gas turbines, and the gas turbine is a very interesting topic because in the modern context, it is very, very relevant. Okay, however, the gas turbines, when we talk about two things in the industry. One is steam turbine and what is called as a gas turbine. Okay, now the steam turbine has been traditionally very, very popular in the main commercial shipping industry. What do I mean by main commercial shipping industry? Traditionally, this steam turbine was used on a category of ships called uh, large VLCCs, very large crude oil carriers. Those ships used to have the steam turbines in place. So then the other area where steam turbines were very popular is the can we mute, please? Right. So the steam turbine had entered commercial shipping, which means that on very large crude oil carriers, we used to have steam turbine. And it also started becoming popular when we started using LNG ships. Whenever you had LNG ships, you had what is called as boil off. Some part of the LNG which is there in your ship will come as boil off, which is wasted. So what they used to do was they used to take that LNG from the cargo tanks, bring it to the engine room, burn it in the boiler, and then generate steam, and that steam will run the steam turbine. Now, the gas turbine, that means, in short, what I'm trying to say is the gas turbine was finding it difficult to enter our commercial shipping market. Now, the traditional place where whenever you talk about gas turbines, you should remember that it was generally very, 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 very popular in the Navy. Okay, in the armed forces, in the Navy, most of the ships that the Navy used to have were steam turbines. The beauty of the steam turbine is that the steam turbine is very small in size, but can generate enormous amount of power, and the engine room size is also very, 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 very small. So it had an advantage. However, in commercial shipping, the disadvantage with a steam turbine or a gas turbine is its thermal efficiency is in the range of anywhere between 30 to 35. You just take a gas turbine. Just to remind you, the steam turbines gas efficiency is even lower. The worst is the steam reciprocating engine, which has got a thermal efficiency of anywhere between 15 to 18%. Then you have steam turbine, which is more efficient. It can go up to 25. The gas turbine is further more efficient, which means if I burn X quantity of fuel, only 30% of the fuel which I burn is going to be generated into power. The rest is going to be used in other parts of the system, which is useless to me, right? However, with modern technology, the efficiency of a gas turbine also has been improved, and progressively we are seeing the gas turbine can, with a lot of other systems fitted to it, can come close to the efficiency of what is called as the diesel engine. So the diesel engine is now very capable of achieving the level of a diesel engine. I mean, the diesel engine and gas turbine can compete each other in terms of its usage. Okay. Now, one major disadvantage which always remained was the gas turbine. Whenever you're talking about, okay, you will always find that you are using what is called as ATF. ATF stands for aviation turbine fuel, which means that that is the one which is used in our aeroplanes. Are you all familiar with ATF? What is ATF? aviation turbine fuel. That is a fuel which is used to run our aircrafts. Now, this fuel generally is quite expensive, and definitely it was one of the reasons why this gas turbines were not very popular. The fuel itself is very expensive, so it became not so popular in the industry. So that was one this thing. However, the gas turbine, because of its small size, can give you lots and lots of advantages. The advantages, because it is small in size, and with a combination of a gearbox, you can have an n number of combinations of power flow. So let us try to understand what a gas turbine plant would look like, and further we will see what combinations of various equipment can make the gas turbine very, very effective. Okay, so let's move on from where I am to where we should be. Okay, so in short, a gas turbine is a fantastic equipment, and ideally, if you want the best performance from the gas turbine, then we are talking of a high inlet temperature of 1200 degrees centigrade, and you could have a specific fuel consumption which is quite low at zero point 0.2 kg per gram per kilometer hour. However, this high temperature that you are looking at also brings with it what is called as NOx. So it is a question of how you balance the temperatures inside the combustion chamber without creating NOx. The other major limitation of a gas turbine is the material. Any material, when you're subjecting it to 1200 degrees centigrade, then there may be challenges with respect to the quality of the material that you're using. Okay, so the latest gas turbines which you are talking about in the aircrafts will use what is called as ceramic blades. Ceramic is the kind of tile material that you use in your house. So ceramic is nothing but silicon dioxide. Silicon dioxide is capable of uh, withstanding high temperature. Okay, so that's the basic introduction. Now let me get into a basic concept of what that gas turbine and what is the cycle on which it operates. All of you remember what is called as a diesel cycle, am I right? An Otto cycle or a diesel cycle, all of you can recall. So if I look at it as an Otto cycle or a diesel cycle, then there is a beautiful comparison that we can make between a diesel and an Otto cycle with respect to gas turbine. Funda is very simple. In a diesel engine, you have what is called as a combustion space. That means there is a liner, piston, whatever it is, and inside that liner and piston, you are having combustion. So, but here there is a subtle difference. In a diesel engine, which means if you are burning on Otto cycle or let's say diesel cycle or dual cycle, at any point of time, either the piston can have on a, because the piston is moving inside a cylinder degrees, can we avoid okay, when you are having a diesel cycle, the piston at any point of time based on the opening and closing of the valves can have only one type of stroke, which means it can either be in intake, or there could be air intake, then there could be compression, or there is a power stroke happening or exhaust gas happening, right? So which means a diesel engine cycle inside a cylinder can have only one type of activity which is happening. Either there is compression, or there is power, or there is exhausting happening, but all at the same time. If I need to have an engine in which everything happens simultaneously, then uh, then we need uh, the not the Otto cycle but a slightly different cycle called Brayton cycle. Okay, so in a Brayton cycle, you will have one part of the system undergoing compression, the other part of the system is undergoing combustion, one part is going through exhaust, and there is air coming in for this thing. Okay, so the difference between a reciprocating engine which is undergoing, let's say, a dual cycle as compared to a Brayton cycle is, in a Brayton cycle the equipment has got different parts in which there is inlet happening. In another part of that equipment, there is compression happening. In another part of the equipment, there is combustion and there is exhaust, which means if I take, let us say at, what time is it now? Let's say it's 11:56. At 11:56 hours, simultaneously at that time, one part of my engine is under inlet, one part is doing compression, one part is doing burning power generation, and one part is doing exhaust. So that is a difference. All four parts of the cycle being put together and simultaneously happening is called a Brayton cycle. So that is a fundamental difference. So when you give any answer, suppose I ask you what is the difference between a reciprocating engine and a gas turbine, you want to say it in simple words, that is what you should be saying. Any doubts on this? Any doubts?
No, sir. No, sir.
So let's explore this basic sketch and then let's increase the complication that we will see in a cycle like this. So at a very low level, if I have to have a gas turbine, okay, so then I am having one part of my system which I will call as compressor. A compressor is supposed to compress air and deliver high pressure air to the uh, to a particular place which I will call as combustion chamber. Okay, and in the combustion chamber there is some activity happening, and at the end of the combustion chamber, hot gases are available to me. That hot gases under high pressure is then sent through turbine blades, which is called as the gas turbine. And the gas turbine will do power by, the blades are hit by the hot exhaust gases. There is kinetic energy getting converted into power, and you have the shaft rotating. Then you have a variety. This is a gearbox. This is a small representation of it. You have a small gearbox or a large gearbox depending on the type of configuration, and then you have the propeller. So the propeller and the turbine shaft, they have nothing to do with each other in a practical turbine. Okay, so you have a chamber which you are seeing. There are some similarities, small similarities, if I may say so, between a gas turbines cycle, Brayton cycle, and the petrol cycle. If you look at the petrol engine, you had what is called as a carburetor, right? What used to happen in a carburetor, in a, you know, in a petrol engine, you had air which is coming in. That air is allowed to mix with the fuel, and when the fuel is mixed, air fuel ratio is good, the air will be sent into the diesel engine. Instead of this, if you think of this part as a diesel engine, that uh, the gas is the mixed uniform air fuel ratio then enters the uh, let's say diesel engine, and then it produces power, and then the gas is exhausted. So this part is like the carburetor of a it's a very poor way of saying it, but air and fuel get mixed here and there is combustion happening. Okay, so that is in short a very basic definition and understanding of this system. We'll move on to more complication. So before we get further, we need to also recall some gas laws which you already are familiar with. So I'll quickly run through. What is Boyle's law? The Boyle's law says PV is equal to a constant, which means my if I increase my pressure, my volume will decrease provided I maintain temperature constant. So PV is a constant. So that is called Boyle's law. Boys, please remember that these questions get asked even in your interview. Huh? So recall this, and sometimes I get embarrassing looks from the superintendents who come and ask you questions. They say, Salah, this boy does not know 12 standard ka gas law. How is he going to work on my ship? So make sure that you know these laws quite well. I don't want embarrassments where boys look at, the superintendents look at me, ki, what the hell you're teaching. Okay, the next law is called Charles' law. The Charles' law says if I maintain the pressure constant in any gas, okay, gas mixture, then the volume increases uh, if I increase temperature, which means I have a gas and the gas is getting uh, is undergoing heat addition. So when the temperature of the heat is being added, and if the heat is getting added to the gas, if you have to maintain pressure constant, then I must increase, allow the volume to increase. Then there is a third law which says, suppose I want to keep the volume constant, let's say for an air bottle, if I increase the temperature of the air bottle by heating the air bottle, obviously the pressure is going to rise. That is why you have a relief valve fitted. The purpose of a relief valve in a bottle is uh, to relieve pressure when the pressure goes beyond a certain value, right? So whenever you have a fixed volume like a bottle which has got air, and which means that the volume of the bottle is constant, and if I apply heat on the bottle, then the temperature will uh, if I heat the bottle, then the pressure will increase. Okay. Now, all these laws put together, if I can add the Boyle's law, Charles law, and uh, Lusak's law, then we have a law which is very familiar to you, which is called PV by T. P into V divided by T is equal to a constant, which means when I do some activity on a gas at pressure P1 and I change something, either volume or I change temperature, then there is a relationship between the first condition and the second condition. So P1 V1 by T1 is equal to P2 V2 by T2. So it's a very important law. So kindly remember this ever in your life. So just to go further, I will mention this law which applies to the we spoke about Boyle's law, Charles' law, and Guy Lussac's law. We now introduce a law which is Joule's law. Joule's law or Brayton cycle. What did I say? A Brayton cycle is a cycle where simultaneously four activities, that is air intake, compression, fuel addition, power stroke, and exhaust, all happening simultaneously. Okay. So that is so when all four activities in any system is happening simultaneously, then the power which is generated, or the energy which is generated of the fuel, is equal to E is equal to mCT, m multiplied by C multiplied by T. What is m? The mass of the uh, gas which is there in the system. Then C is the specific heat. It could be uh, either specific heat at constant volume or at constant pressure. And T is the change of temperature. It is not T, it is delta T actually. Okay. So change in temperature. So it is incorrect to say T. It's actually, I made a mistake. It should be written as delta T. Okay. Or T2 minus T1. Sorry, 1 minute. Okay, it's delta T, not T. I'm sure you have read it earlier that the ratio of Cp by Cv is called gamma. We have already discussed that this is called as the adiabatic constant or gamma. Can anybody recall the the Otto cycle's efficiency, thermal efficiency of an Otto cycle? Anybody? Otto cycle efficiency. Nobody is willing to tell me the answer. I'll tell you the answer. 1 by 1 minus ratio of the compression ratio to the power of this gamma minus 1. That is the basic efficiency of a diesel engine. Not diesel engine, the Otto cycle. Okay. typical value for gamma for a engine is typically 1.4. Sorry, I have to go further. Yeah. So the theoretical cycles I've already discussed with you. So I'll move on from here. So I've discussed this basic part, so I don't want to repeat it again. Then, yeah, this is very important. If you recall the previous one diagram which I showed you, we will move on to Brayton cycle. Okay. So in a Brayton cycle, you have something very, very similar to that PV diagram that you were exposed to earlier. So there is one difference in the Brayton cycle. In a Brayton cycle, if you take it as per time, then one part of my system is undergoing compression. There is heat addition. There is power being generated, and this is called air addition. The air is coming from the atmosphere. So this part of the cycle uh, is happening from the atmosphere. Okay, so from the atmosphere, this is coming, this is shown as dotted line. That is a subtle difference between a Brayton cycle and a typical PV diagram that you find in a dual cycle. Moving on, we have to see what are the advantages and disadvantages. It's a very interesting topic. Huh? We'll first discuss the advantage, then we'll talk about the disadvantages also of the steam plant, the gas turbine plant. Okay. As I told you, a gas turbine is a very, very small and compact equipment generating enormous power. So its basic advantages, it is very small, which means that I can generate a lot of power giving a small volume, which means my engine room space becomes small, and I can have large cargo area or other uses for commercial reasons. I can use it. Okay. The gas turbine requires very, very, very high mass flow rate, which means to compare a diesel engine generating power and you compare a gas turbine generating power, I'm not talking about size. The amount of air that is consumed in a gas turbine as compared to the air that is consumed in a diesel engine when it is generating same power, you can say roughly 5 times more air is required in a gas turbine as compared to a diesel engine, whether it is 2-stroke, 4-stroke, which is generating power. So that is the very, very subtle difference. That's why whenever you are standing in front of a, how many of you have traveled in an airport? So when you stand in the airport and if you stand near the turbine of the aircraft, you must have seen in movies that the mass flow rate is so high that you will get sucked into the turbine inlet. So that is the amount, almost 5 times and even more, depending on the power and the design of the plant. Okay, the engine may be small, but the air inlet passage, the air exhaust passage, etc., have to be very, very substantial and heavy. So that is one thing that you must remember. The third thing is you are generating a tremendous amount of power in a very, very small space. The temperature that you are going to subject the gas to is going to be in the range of 600 to 1200 degrees centigrade, which means that you need to make sure that the material can withstand such high temperature while it is in service. Okay. Now, there are some challenges when you use gas turbine on board a ship. The reason is whenever you are at sea, you will have what is called as salt, which is always present in the seawater when the waves are moving or when there is wind. Salt from the sea is all many times mixed up with the air which enters the ship through the air intake filters. So you will have salt which can damage the turbine blades. Okay, that's one. Looking on the most important part, which is your engineer's perspective. Okay, for an engineer, a gas turbine is a beautiful equipment, but there is not much to learn. Whenever you are having a gas turbine plant, there is no job for an engineer. The reason is it is a very, very small plant. You don't have to remove this fuel valve. You don't have to remove the intake valve, exhaust valve. So a typical gas turbine, a set of engineers will come on board. They will completely strip it, which means you cannot do it on board the ship. So a set of service engineers will either come on board and dismantle the entire shaft, the entire engine, and then take it or service it and then put it back. So that is what typically happens in a gas turbine plant. I have seen the Indian Navy where the gas turbine, plant is there. So in Indian Navy, the gas turbine plants, what they do is whenever they have to do maintenance, that is full complete maintenance of the gas turbine, all they will do is they'll take them to there is a dockyard called Naval Dockyard in Bombay, or they will take it to Cochin Shipyard. Then what they do is they will cut the hull plate at near the turbine. They will completely dismantle the turbine, take the complete turbine out of the ship, completely overhaul it, and then come and reinstall it. So for an engineer, he has to only take temperatures and other things, which means his job is reduced. One major disadvantage of a gas turbine, if I can call it this way, which is really relevant and important, is that your diesel engine, though it can operate at part load very comfortably. If you are using VAT, then if you are able to adjust the exhaust valve timing, opening, closing, if you can change the fuel timing, when to supply fuel, when not to supply fuel, you can produce decent efficiency in the diesel engine. However, in a gas turbine, well, that is not possible. The major advantage of a gas turbine is you have a gearbox which does all the work for you in terms of reversing the engine. So that is an advantage, which means that the engines, you don't need distributor and other equipment that the way we discussed for diesel engine starting mechanism. Okay. The most difficult thing when you're working on a gas turbine is the extremely high noise levels, which can be very irritating. If you have been in the airport anytime, and if you have seen the aircraft, when it is about to start the engine, and once the engine starts rotating, nobody can stand near it. It's so noisy and uncomfortably noisy. So this challenge with respect to the engine room staff facing very, very high noise level is something which needs to be taken into account. So for that, you have all special earmuffs provided for you. Okay. So we are talking of thermal efficiency of gas turbine, which is not great, but with a lot of modifications, now gas turbines are as efficient or even more efficient than the diesel engine. Okay. Now, one thing which I mentioned earlier, I will repeat again. This gas turbine cannot use heavy oil, which means you need to burn aviation turbine fuel, which is like kerosene. So burning kerosene is costlier than burning residual fuel oil, which you call heavy fuel oil. Advantage is the engine room size is small and a lot of things can be saved. Okay, then we will move on to what is basic parts of the gas turbine. Now the topic is going to get very interesting. So you will have in any gas turbine, you will have a way of Chandru, you are coming in and going out often. Is that your bandwidth is poor or what is it? Chandru? Okay. Boys, you're able to hear, right?
Yes, sir.
Okay.
Yes, sir.
So, see, I think I will finish this topic only tomorrow. because a lot of things have to be discussed, but we'll see how to manage the other things. Okay. Uh, okay. Now, the various parts of the gas turbine are very simple. You need to have what is called as an air compressor and something to feed the air in the air compressor. Then you have uh, a chamber like this, which is shown to you here. Here is where the air which is coming in, which is compressed, is fed into this chamber. Then there are some fuel injectors and spark plug. So once you have the spark plug running, and you please remember that there is no auto ignition here. Huh? So there is no auto ignition, which means that the air which is generated should have a spark plug, some means of continuing to supply spark using which the fuel is going to burn, and at the end of it there is a turbine. The turbine is like the turbocharger that we are talking about. It is a multi-stage turbine. So then the output of the turbine is the power which is generated. After this, the turbine exhaust gas is coming out. The exhaust gas can be reused for heating the compressed air so that you can get more efficiency. So if you look at this part, the biggest part of the, if you can call it, this is a full gas turbine, is your air intake part, where you're compressing air in multiple stages to create high pressure air, let's say of 6 bar or 7 bar. Then you will be supplying fuel and then burning the fuel with the air which is coming in, and then the turbine part and the gas leaves the turbine. Okay. So basic components, you have a compressor, a combustion chamber, a turbine where the power is being generated, and then you have the exhausting. Now, so just a little more details. So there are two types of compressors which could be used. Uh, Typically, the radial or centrifugal compressors, which we spoke about in turbochargers, okay, these may be used, but they are not very efficient. So this type of compressor will not be normally used. The one that we generally use in gas turbines is what is called as axial flow, where the gas is going through various stages and getting compressed. Okay, so this typically, what you're saying is a full compressor. So you will have stages. So after one or two stages, the gas will come out. The air which is getting compressed will come out. Then it will go through what is called as intercooler. Then enter the next stages. So that part we will discuss. Okay. So that, like in any compression, whenever you compress a gas, heat is going to be generated. That heat is not very useful. So you have to pull out that heat and uh, go ahead with the compression part. So when you're satisfied with the compression, then you release air. That is what we need in a compressor. Okay. So the type of turbines are, it is more or less very, very similar to the turbocharger turbine. Only thing, it is multi-stage. So one stage to the second stage and third stage. Okay. So that is the turbine part of it. Uh, so what are the gas turbine accessories? So how do I start my gas turbine? So to start my gas turbine, I need some way of starting it, right? So for a simple gas turbine, you will have, as I showed you in the previous diagram. Yeah, I showed you a previous diagram. So if I have to start this gas turbine, I will have a small electric motor. So I supply electricity to this motor. So that when the motor shaft rotates, the turbine, the compressor shaft starts rotating. When the compressor shaft rotating, if it is directly coupled, the turbine will start rotating. So basically, you need a means to start the compressor, I mean the turbine. So it could be electric, it could be hydraulic, or it could be pneumatic, okay, depending on the type. So, so you start the compressor shaft. So the compressor is connected to the turbine. So the entire shaft starts rotating. However, many times this interconnecting shaft might not be there. Huh? So then this can run at some speed, this can run at some speed, and there could be some other means connecting these two parts. So that is also possible. So a means of starting, then to once the minimum RPM is reached, you need to inject fuel, and then the spark is ignited, and then you need the reduction gear and other equipment for driving it. So simple funda, a starter for starting it, air in large quantities to be sent to this compressor. The compressor will compress. What they have not shown you is the intercooler and other things which are part of this. The air enters, there is a fuel injector and a spark plug. So air is coming, I mean the combusted gas at about 700 or 1000 degrees centigrade coming, running the turbine and rotating the shaft. So this kind of a shaft is not very efficient because, as I told you, only 35% of the power fuel is getting converted into power at this end, okay, and 60 to 65% is getting wasted in trying to move this compressor or and this turbine and delivering power to this. So we have to find more efficient ways of using this plant. Okay, so we move on here. So this is just the same thing. Sorry, I'll move on to this. Yeah. So a little more, we will talk about dual shaft. So this is a dual shaft, split shaft. So I told you initially that you can have a starter here, correct, on the left side, and then you have the turbine generating power here. Instead of that, I could have a some kind of a starting mechanism here using a gear, and once I rotate this entire shaft starts rotating, and then you deliver power here. Okay, that's also possible. Then we'll get on to the most important diagram that we have here. Generally, this is used or generally asked in exams. Huh? So kindly note this point. So I'm giving you a broad, big hint. Smart people will understand. Okay, let's talk of a practical gas turbine cycle where I have to intelligently use a small space in the engine room, but I need very high efficiency. So how do I do it? So I have set up a gas turbine, okay, in which there is a high pressure compressor and a low pressure compressor. There is a high pressure turbine and there is a low pressure turbine. I am also going to use the exhaust boiler for or a heat exchanger here and an exhaust boiler. All this I'm going to use to improve the efficiency of my engine, okay, my gas turbine. So let's look at this open cycle gas turbine. Uh, so so whatever you're seeing, the HP turbine and LP turbine, they are shown physically separate, huh? But actual engine, this HP stage will be fitted here next to this thing. Only thing physically they are showing you as different. Okay, let's try to understand this. So you have HP compressor, LP compressor, sorry, turbine here, HP compressor, LP compressor. Now let's talk of this cycle. There is a combustion chamber here. So what will happen? In this diagram also, please note the temperatures. Huh? This is pressure, 6.2, 2.1, etc. And the next to it is the temperature. Okay, so observe this at various parts of this cycle. Okay, I'm having atmospheric air entering the LP turbine. Okay, now hello, just one second. Prakash, நான் வந்து ஒரு half an hour அப்புறம் உங்ககிட்ட பேசட்டுமா? இந்த கிளாஸ் முடிச்சிட்டு வரேன். Okay, நான் ஒரு half an hour கால் பண்றேன். Okay, okay. Sorry boys, I had a call from my department. Okay, so you have air coming in the LP compressor. From atmospheric pressure, the air is going to get compressed to about 2.2 bar, and the temperature of the air has come down to come up to 110 degrees from, let us say, engine room temperature. Okay, from engine room temperature, the temperature become 110. So the 110-degree air is now cooled down to engine room temperature, which is 38 degrees centigrade. Then it goes into HP compressor. HP compressor is raising the pressure to 6.2 bar and the temperature of the gas is increased to 160. So as the temperature of the gas is increased, you will be sending it to a chamber called heat exchanger. And then from the heat exchanger, it is going into the combustion chamber. Okay. So you are supplying fuel, which is coming through a separate line, going inside the combustion chamber, and the temperature of the gas is at the compression chamber outlet is 6 bar and 650 degrees. So the hot gas is now rotating the high pressure turbine. Then the pressure drops to 3.2 bar and the temperatures come down to 530 degrees centigrade. It comes to the LP turbine. So it rotates the LP turbine. The pressure is down to 1.1 bar and temperature is 330. Then the gas is going through the heat exchanger. And then after it goes to the heat exchanger, it then goes to the exhaust boiler. So this is the basic cycle. So what have we tried to do here? We have used a intercooler in between the LP compressor and HP compressor. And then we have taken the gas and utilized some of the heat in the LP turbine. The outlet of the LP turbine is at 350 degrees. So what I did, I use a heat which is available in the LP turbine and I heated up this gas and the temperature of the gas went from the air which is coming from HP turbine. It was at 160 degrees. It came up to 290. So at 290 degrees centigrade, I supplied air and I supplied fuel. So the temperature of the gas became 650 degrees centigrade. Okay. So when I release the air through the exhaust boiler is this inlet is 230 degrees centigrade, and whatever steam that you're generating is because of that. Now, what all things I've added? I have added a lot of auxiliaries. Whenever you are having a gas turbine, because you have gearboxes, so different parts of the turbine, of the gas turbine machinery can be used to drive different things. So apart from driving the turbine, I'm also driving an electric motor, which is called as power takeoff. Okay. So I'm having power takeoff where I'm generating rotating motion and generating electricity. Okay. And it is converted this. Is there any doubt in this? Any doubts, boys?
No, sir.
So this LP turbine and HP turbine is on the same common shaft or
Yes,
or
it's the
different
same
shaft?
common shaft. It will look like this only. For you, you cannot make out. So what is
Yes, sir.
happening is, let us say this is the HP part of this turbine. So the gas will come here. It will come out like this. Then if there is a heater provided here, it will go through the heater. Again, it will come like this. And then do work here. And then after that, it will go to maybe one more turbine if they have designed it that way. And then the power will be received here. So air is coming here, getting compressed initially in LP. Then the air will come out like this and get intercooled, and then it will enter this like this, and then enter maybe through the heater into the combustion chamber. Right? So that is the basic cycle. This is a very important diagram, by the way. You must know this by heart because it will come in some form or the other in an exam. So what is a regenerator? A regenerator is like a heater. What is the purpose of a heater? The purpose of the heater is to heat something which is passing through it. So the exhaust gases which are coming out of a turbine are passed through the regenerator or heater, or we also call it recuperator, R-E-C-U-perator, P-E-R-A-T-O-R, recuperator, and the gas is taken upstairs. So when compressed air is passing through this, the temperature of the compressed air is increased, and then you have combustion here and then going out. So this is a recuperator. So a typical cycle will have a compressor. Chandru is going in and out. Okay. So there will be a compressor and there will be a cooling which is called intercooler, and this part is easy, I think. No? So we'll move on to the thing. So the work done in the turbine is an isothermal. That means same temperature can be achieved. So I'll move on from here. So there are, I think you can read this. I don't need to. Okay, you can go through these things. I will also talk about. One minute. Huh? Yeah, this is how a typical turbine will look when you dismantle it. So you have the compressor side, and then you will have the combustion chamber, which is shown here, and then the gas will enter this and the gas will exit from here. So that is a typical turbine that you will see. I'm not going to talk about this. Yeah. Okay. So pretty much I've covered the very basic. Now, which are the type of ships nowadays which are using gas turbine cycle? The gas turbine cycle is generally being used by today, as we talk today, cruise ships, because the purpose of a cruise ship is luxury. And the size of the engine room has to be very small, and for that reason you have cruise ships which are using this turbine principle. Then you have passenger ferries which are using this very extensively on your ships. Then you will have LPG and LNG carriers which are using this gas turbine cycle. Then there are some important points. If all of you have got paper and pen.
Yes, sir.
Okay, so there are some cycles which I'll discuss in the next class, which is called combined cycles. So I will try and discuss those cycles in the next class. So far, you were able to understand the fundamental concepts of a gas
Yes, sir.
turbine cycle.
Yes, sir.
Okay. So the key question that comes out is, who are the manufacturers? Like I told you, BMW and Sulzer. So which are the major manufacturers that you can recall?
Kawasaki.
Kawasaki, because I showed you. Which are the very big names? Any other names that
So Honda.
BMW.
Unfortunately, that is not a major player.
The
Okay,
whole
I'll tell you the
station.
big companies which are in this space. You heard of a company called General Electric, GE. All your aircraft engines are made by two very big companies. Called one is called General Electric. The other one you must have heard called Rolls-Royce. Sounds familiar? Rolls-Royce.
Yes, sir. Yes, sir. Yes, sir.
Yeah. Then there is a company called ABB. It is a Swiss company. They make all your turbochargers are made by BBC or ABC. ABB. So ASEAN Brown Boveri is a company. Then you have Mitsubishi, which you mentioned, Kawasaki, Volvo, and there is a French company called Alstom. So they make this equipment. Okay, so the advantage of the gas turbine is that the entire combustion is a continuous process, which means that while I'm running the combustion, one part of the other cycle is also doing some of the work. Okay, so that is one major advantage of the gas turbine cycle. Then anything else that I wanted to tell you? Basic things. Yes, I have covered most of it. Kindly go to this thing. Then the cycles. I told you about. What is the typical efficiency of a gas turbine?
35%.
Yeah, 35%. So when you combine the cycle, we'll discuss in the next class and make it a little more complicated. Then there are formats which are called just write it down if you have paper and pen. Capital में लिखो वहाँ सब चीज. COGAS, co-gas, combined gas and steam cycle. COGAS. What does that mean? If you have a propeller, then I can use one gas turbine and I can also use a steam turbine. So one gearbox will receive power from a gas turbine which is generating power, and on the other side I also have a steam turbine. Where will you use this kind of a power? Say in the same engine room, I have a steam turbine also, I have a gas turbine. I told you about a type of ship which generates boil off gases. Boil off gases. I told
LNG,
you
LPG
one ship's
carriers.
called LNG ships, where there is boil off gases, right? So when you have boil off gases, then there is these boil off gases are burnt in what is called as the boiler. So boiler will generate steam. The steam generated will be used to run one steam turbine, and there is also a gas turbine which is running. So from the for the gearbox, the gearbox will receive some power from the gas turbine, and it will also receive something from the steam turbine, and combined together they will be able to deliver power to the final propeller shaft. Okay, there is another format called CODAG. So what is CODAG? Combined diesel and gas cycle. Okay, CODAG. Then there are just write it down. There is another cycle called CODOG. CODOG. Okay, and there is a cycle called CO. I will write it and give it to you tomorrow morning. Okay, so we will be discussing all these cycles in the next class. Okay, now how was the discussion basically today? Okay,
Awesome, sir.
so you have got the basics. I have
Very
also
nice.
given you a broad hint.
So really interesting, sir.
So this is the future actually, because the your NOx is become very critical, and if I use only diesel engine, then I am going to create a lot of NOx. So for NOx prevention, there are various means which are provided. Suppose I consume less of heavy fuel oil and I use an oil which has got very little sulfur, right? So for I can combine the one side I can run a gas turbine which is going to use, let us say, kerosene, and on the other side I can use a diesel engine, burn some quantity. The power generated with the diesel engine can be combined with the power that is generated in the gas turbine, and then the output shafts can be one or two. The advantage are many. So we will discuss about the beauty of this multiple combinations of power that can be generated. Okay. So that will make it interesting. So kindly read the material. Anybody saw the videos that we spoke about? If you didn't get time, that's also okay. We can discuss in the next class.
Yes, sir.
Okay. So don't worry. My intention is to make sure that many of you get at least some bit of knowledge. So thank you for coming for my class today. I will have to move out. I have a call which I received from my colleague. So I need to look into that. Okay. The next
Okay,
class,
sir. Stay safe.
so what we'll do is next class we will finish up this gas turbine part, and then we will either discuss a video, or we can start with what is called as the assignment questions. Okay.
Yes, sir.
So I suggest that you should keenly watch all the videos, because you people have not seen engines, and the videos will give you an idea about what is a practical engine and how it is going to look, how you will be able to overhaul it, so you will be able to understand these things better. Okay. So thank you so much for attending my class, boys, and have a great day. I assume that it was quite interesting.
Yes.
Yes, sir. Yes, sir.
Okay. Take care, boys. God bless you all and stay
So you
safe.
too, sir.
And I hope all of you come back healthy.
Yes, sir.
Do wish me the same, me and my family, because
Yes, sir.
very close to my house also there is a COVID case which has come. So they have blocked all the roads leading up to my apartment. So stay safe and stay healthy and try to help your mother and father. Don't treat them as your servant.
Yes, sir.
Because I keep telling my
Yes, sir.
daughter, your mother and father is not your servant. When you are normally studying, they will try to help you. But now you must help your parents in whatever way you can to, make them feel comfortable in these difficult circumstances. Thank you all. Bye-bye.
Bye, sir.
So thank you, sir.
Thank you, sir.
Okay, bye. Thank you.
Bye.
Bye.
Bruna.